Oke, assalamualaikum. Welcome guys. Kita akan terusin lagi tentang pembahasan ini. Sebagaimana pada kesempatan sebelumnya kita juga sudah membahas berkaitan dengan atomic structure. Bagi yang masih bingung kita lagi membahas apa, kita lagi bahas soal-soal standar, soal-soal kimia terstandarisasi oleh ACS atau kita bisa sebut dengan ACS exam, di mana ACS exam ini sekali lagi adalah ujian untuk teman-teman kita yang mungkin di undergraduate untuk lulus atau untuk melanjutkan ke graduate student. Mereka harus belajar tentang ini, maksud saya itu harus melewati tes ini dulu gitu kan. Nah, pada kesempatan sebelumnya saya banyak memakai istilah-istilah, saya pakai kebanyakan bahasa Inggris ya. Sama dengan kesempatan kali ini juga saya ingin coba banyakin bahasa Inggrisnya daripada bahasa Indonesianya. Ya, sekalian kita mencoba untuk melatih diri kita agar lebih bagus ya, lebih bagus dalam artian memahami konteks soal-soal kimia dalam bahasa Inggris daripada kita selalu pakai bahasa Indonesia, yang mana nantinya kalau kita sekolah di luar negeri itu bingung kalau kita cuma pakai bahasa Indonesia terus. Nah, pada akhirnya ya saya akan banyak pakai bahasa Inggris. Mudah-mudahan bisa membantu kita semua, terutama untuk saya pribadi, agar saya bisa speaking yang lebih lancar lagi, especially about chemistry stuff, right? Because each term in chemistry, or whatever language we speak, right? Whatever language we speak, for each field, it has kind of like, I can say, like specific term for each subject. For example, chemistry, and then it might be different if we are discussing with another subject, kind of like maybe social or others. Okay, so yeah, welcome to the chemistry field, so we can understand a bit more, in specific manner about chemistry stuff, not just like common words in our daily activities. No, not something like that. So we need to do like improve, yeah, we need to improve our speech in specific field that we want to acquire. Okay, so first of all, the previous question we already discussed mostly, like the previous one is from number 1 till 10, and then as well as for the like preparation exam, and then so we do we did both between the like preparation, and then the next step is kind of like we do like the actual exam. Okay, so yeah, but it's actually same. I mean, the level of the difficulties is same, so it might be not much more difference. I mean, it doesn't have any significant difference between practice and then like the preparation stuff. Okay, so now we are on the I just want to make sure we are on the same page. I mean, we are on the same page, which is I'm discussing about the ACS exam, where we are discussing for the real exam. I mean, for the real question, kind of like this one. Okay, so let's get started. So number 11. So we already discussed from 1 till 10, and then we also discussed about the preparation exam, which is we discussing some materials as well. So over here we have question about number 11. Which ion has 26 electrons? Okay, which ion has 26 electron? Okay, like I mentioned before, that the electron, okay, electron should be same with proton if neutral. Okay, if the if the element like neutral, not having any overall charge, like not having any charge. So in this case, we can see that all of option, okay, all of option have charge, which is impossible using this concept. So how to get this one done? So we are looking for an ion that ends up with 26 electron after counting for its charge. Okay, let's break down one by one. So for the option A, chromium 2 plus, okay, so atomic number is 24. So we need to determine the atomic number first by looking at the periodic table directly. So if we are looking at the periodic table, I will show you over here. So we have the periodic table, and then you can take a look at like chromium. Okay, chromium. See over here we can see the chromium, it should be like 24. Okay, 24. So this is the number of the atomic number. So and then okay, we know that the atomic number is 24, and then we understand atomic number represent the proton. Okay, atomic number represent the proton. Okay, so proton, this one is atomic number. Okay, atomic number. Okay, so we understand here is 24, and then this is not so we assume we have the neutral atom, which is 24. Okay, we assume chromium doesn't have any charge. First in first. Okay, firstly we assume this one like zero charge, so it should be 24 whether for proton or electron. So we assume that one is 24, and then it has 2 plus, which is it lost losing two electrons. So we can like ended up getting the number 2 over here, -2, or like we need to getting opposite over here. So if this one is +2, this one should be minus. Okay, so this one is 20. And then for P, Fa2 plus, Fa, we can understand the atomic number is 26, and then -2, and then we can get here, this one is 24, and then for C is nickel 2 plus, and then nickel 2 plus, we understand this one is nickel is 28 if we are looking at the periodic table, and then -2, and then we ended up getting 26. And for option D, we have C culprit 2 plus, and then atomic number is 29, and then -2, so 27. Okay, so the answer is should be C. Okay, nickel 2 plus. All right, and then a sodium ion differs from a sodium atom in that the sodium ion. So jadi di sini ada pertanyaan, di sodium ion itu berbeda dari sodium atom. Kenapa? Gitu loh. Kenapa? Apa bedanya di sodium ion? Okay, we understand that the sodium is we can understand that sodium is Na plus, right? For example, Na plus. This is the ion. Okay, so we understand it lose one, yeah, it lose one electron. Okay, it lose one electron. So we understand it should be it has less electron rather than proton. Okay, so the answer it should be A. So has fewer electrons. Okay, so for the sodium atom, okay, for sodium atom, the proton is same with the neutron. So we understand the number, I mean the atomic number is 11 over here. So proton is 11, neutron is sorry, this is electron is 11. Okay, so by using this concept, we can get the answer directly from here, that sodium ion will lose -1. Okay, we lose one electron, which is, we can conclude that the sodium ion has fewer electrons. Okay, isotope of sodium, no, isotope, we understand the meaning of isotope is if the element has same, okay, has same proton but different in neutron, okay, but difference in neutron. All right, and then we move to number 13. Okay, we are moving to number 13. Okay, all right, number 13. Which ion has the same number of electron as argon atom? Okay, in argon atom. So argon or argon, I don't know how to spell it correctly, but you know argon, right? Argon, AR. So atomic number is 18. Okay, atomic number is 18. Okay, we already knew like the atomic number of this one. So which is argon atom, which is neutron and electron and proton is same. It should be 18 because it's neutral. Okay, and then the question is which ion has the same number. Okay, so we will inspect or check one by one. Okay, Mk2 plus, Mg2 plus is, Mg is 12 minus 2 because this one is 2. Okay, it has 10 electrons. Okay, and then chlorine, it like 17. Okay, 17. Okay, 17 minus minus, this is minus, it should be plus, and then the result is they ended up like 18. And then after that Na, okay, Na, Ne, okay, Ne, so this is Ne, so neon, okay, neon. So from here we can get the neon, it should be 10 electron. Okay, the number of the atomic number of neon is 10, so it should be same. Okay, 10 electron. And then the last one is Na, okay, Na, sodium. So like we discussing above, we discussed previous one, it's 11, so 11 minus 1 and then 10 again. So the answer is should be 18, so the answer is B. Okay, we got it. Okay, we got it. All right, this is the question for number 11 till 13. Okay, so and then we have another question over here. We have another problems about the abundance. Okay, the relative abundance. This concept we already explained it one by one, and then you can take a look at my previous videos how to like deal with these problems, because we need to understand the concept, like the conceptual of this problem. Okay, if we just if we only memorize without knowing the concept behind it, it will be disaster when we have like when we face another type of question, like maybe they are changing something a little bit different, but we do not, we couldn't solve it because again we do not understand about the concept behind it. All right, so let's go through question 14 and 16. Okay, let's go through questions 14 till 16 step by step with clear explanation. Okay, question 14, right? What is, like, bromine has two naturally occurring isotopes. Okay, the most abundant isotope is 50%, is this one. Okay, of mass 78 AMU. Okay, AMU. What is the other isotope? Okay, what's the other isotope? Okay, yeah, we are told about one isotope. Okay, one isotope is this one with the mass, with the abundance if around this one. Okay, so 7935 bromine, it has abundance around 50.69%. Okay, and with the mass, mass is around 78.9183. Okay, and then before we are going to another before we are going to solve or answer this question, we need to we need to know first from the periodic table the average. Okay, the average, okay, atomic mass, average atomic mass of PR. All right, we need to understand from here. So if you are take a look at the PR, okay, over here, bromine, okay, it's kind of like it's like a little bit like it's blurry, but I already note like 79.9. Okay, 79.9. So first in first, you have to understand the question first. Okay, and then take a look at the periodic table to get the average atomic mass, which is 79.90. Okay, all right, this is the average. And then since the average, okay, since the average is close to 80, this is close to 80, right? Okay, the isotope must be heavier, okay, heavier than 79, okay. So in this one, we can see in this one is 78.9, and then this is the average is 79.9, and then we just assume that this one close to the 80, and then we can look at the option whether there is a like atomic number. Okay, there is the weight, okay, sorry, so there is a weight that is close to 80. Okay, so this one it should be eliminated. This one it should be eliminated because what? Because 81 is far away from 79.9. Okay, we have different option here, 79 and 80. 79 and 80. Okay, so regarding the average atomic mass of bromine, we understand it might be the answer, it should be C. Why? Because it close to 80. 79.9, it close to 80 rather instead 79. Okay, so instead of like choosing 79, we prefer to choose 80. Why? Because the average atomic mass it's close to 80. We do not we don't need to okay, we don't need to let me think first. 780. Okay, let me think first. What's the answer for this one? Wait, because it might be B or D or C, but I'm pretty sure not A. Okay, I'm pretty sure not A. So we need to do some calculation probably. Okay, we need to do some calculation probably. That's interesting. So the answer not C, I think. Let me think first. Why not 80? Why not 80? Oh, okay. Okay, guys. Okay, I got the answer. So 79 and then okay. Yeah, we can do calculation. Okay. We can do calculation. How to do it? Let me think first. How to do it? Mm, okay, I mean, I think I can guess, but I don't think so. So it might be not using this option. Sorry, it might be not good if using this option, but sometimes we can get the answer. But to be sure, okay, we need to do calculation. To be sure, I'm pretty sure if we are doing calculation, it will be right. Okay, it will be right rather than just guessing. Rather than just guessing or using the logic. But sometimes it works. But to be sure and then to be safe, please do calculation. Okay. All right. Now we are doing calculation. Okay. Bromine to isotope. Okay. 79 bromine. Okay. And then the average mass is 79.9. This is the average. This is for the first isotope. Okay. This is for the first isotope. Okay. It has 50.96%, and then we can assume, okay, let's assume x, okay, mass of the unknown. Okay, this is mass. Okay, mass of the unknown. And then you, as you can see, abundance of this one is like 0 0.5 0 point, okay, sorry, 0.5069. So abundance of isotope, all right, abundance of isotope, it should be like abundance of unknown isotope, it should be like 1 minus 0.5069, which is 0.4931. Okay, so why we choose 1? Because we assume we have like 100%, so 1. Okay, 1 minus this one, and then we get this one. This is the mass of unknown of the isotope. Okay, we know the unknown isotope of the abundance of unknown isotope. Okay, now we can set up the equation. So remember this equation. Okay, average. Okay, average. Okay, average. And then we can do calculation kind of like this one. 0.5, okay, 0.5069 times this one, 78. Okay, this is weight, 78.9183 plus, okay, plus as you can see, the another weight, I mean the another weight of another, like the another weight of unknown isotope is 1 minus this one, so it should be 0.4931. Okay, like I mentioned before. So this is mass of the unknown isotope. Okay, mass of the unknown isotope. And then we put in plug here, and then times what? Times times x. Why? Because we don't know. We need to determine this part. Okay, we need to determine this part. And then we already know the average. This one is 79.9. And then we can do some calculation over here. So we already got this one is 39.997. And then plus, how about this one? Like 0.4931x. So by using like solve for x, we can determine for x here over here. So remember this equation. Okay, remember this equation. So how to solve it is pretty easy. Just x, all right, x, all right. So 79.9 minus 39.997 divided by 0.4931, and then we ended up getting 80.93, and then we can rounding this one to be 81. So to be sure, we have to have we have to calculate, and then we ended up getting the answer of D. Okay, We ended up getting answer D for this question. Why? Because isotope is the same number. Isotope is same proton but different neutron. Different neutron. Why are we not choosing for B, right? Because the proton is different. It's already different. Okay, all right. So this is for number 14, and then we move on to another question again for number 15. Okay, to isotope hypothetical element X exists with abundance of 30% for 100 eggs and 70% 101 eggs. What is the approximate atomic mass of eggs in atomic unit or AMU? How to do that? Still, again, we have to use the calculation to be sure our answer correct, not just using the logic. So I suggest you guys to use always using the calculation when we face the question about relative abundance, something like that. Okay, so to isotope, we can understand from here it has 30. Okay, just like the previous one, average. Okay, what is the approximate atomic mass of X? Okay, the question is atomic mass of X. And then like the previous average is like this one is 0.3 times 100. Okay, from this time this. Okay, and then plus this time this. Okay, 101 times 0.7, right? We got over here, so 0.3 plus, how about this one is 7, oh sorry, this one it should be 30, this another one it should be 70.7. So what the average here is 100.7 AMU. So atomic mass of this one, like the average, this one, okay, represent average, should be C for the answer. Okay, so excellent. All right, and then we want to identify, this is the conceptual question. So an enriched sample of carbon contain 20% and then 80%, 13, and then 12. Which figure that like shows this sample? Okay, shows this sample. It's very easy. We need to count how many dots over here, like 1 2 3 4 5 6 7 8 9 10. Okay, so we assume all of them has 10, right? This is also 10, this one also has 10, this one also has 10. All right, so all of them has 10 dots. And then that's more like, that's so easy. That makes this question so easy because we can assume the total is 100. Okay, total is 100. So for 12, like for the 12, see, from the key, the dot with the black dot here, it represents 12, and then the circle one without the black color represent 13. Okay, so you want 20% of black one and then 80% for the only the circle one. Okay, so for every dots, 2 should be dark and then 8 should be clear. Okay, so the answer is should be C, only diagram C that show two solids. Okay, two solid black solid over here, and then 8 the hollow. Okay, 8 hollow. Okay, hollow circle over here. All right, so we solved the question from 14 till to 16. Right. We are moving to another question right now for the number 17 till number 20. Okay, number 17 till number 20. How many questions that we have? How many questions? We have like 30 questions. 30 question, but I promise I will solve all of them together. I mean, I will solve all of them soon, and then I can explain it to, I can explain it clearly. Okay, so let's move on to another question for number 17 and then till 20. But for the rest question is kind of like pretty quick because we just need to like see the periodic table and then matching between the periodic table with the equation. But remember, when we are facing this exam, we just have like symbolic with the number without any kind of like different kind of symbol. I mean, like in the common periodic table, right? In the common periodic table, like there should be having symbol. What's the symbol? It is kind of like maybe a carbon. There is a like C and then carbon below, the text below of that symbol, there is a carbon. Okay, but in the exam we don't have any kind of the information what type of this one. For example, we don't know what's the BR means. BR is bromine, right? But if we don't remember it, it might be trouble. Okay, we're getting trouble because we don't remember it. Okay, at least we understand a little bit. We don't need to memorize everything, but hopefully by doing those, I mean by through like by doing through this question, we can understand a little bit about the periodic table. All right. Okay, for number 17, let's break down and explain questions 17 till 20 step by step. For number 17, lithium has two naturally occurring isotope. Again, about everything should like kind of like all of them about isotope stuff. Okay, 6 and then 7 with masses 6.0 and 7.0 respectively. What is the relative abundance of each isotope? Okay, what is the relative abundance of each isotope? Okay, how we can get it? We need to get the average mass of lithium in the periodic table. The average one of lithium, okay, is 6.941. Okay, so we know from here, so we can put in 6.941, and then because we already understand, so we assume, okay, we assume x. Okay, let me break down much more clear. Okay, so assume x is equal percent of 6 lithium. Okay, and then plus minus x, it should be another one, x of 7 lithium. Okay, to be more understandable, we have to give like assumption over here. Okay, and then how to do that, how to solve the problem is now it's just doing like mathematics stuff. 6.941 and then 6. Okay, 6.015 times how much it is, x, right, times x, and then plus, okay, plus 7.016. Oh, sorry, it should be the times 1 minus x. Okay, so just do the calculation stuff right now. So we already get some stuff. Okay, so it will be 6.015x and then plus 7.16 and then minus 7.16x over here, 6.941. Okay, and then 6.941 minus 6. No, it should be minus 7.016, and then we can do another calculation. 6.015x minus 7.16x. So by using this equation, we can get around some calculation. Okay, we can get some number over here. Okay, so how to solve this equation? So we will get some kind of like interesting here, because for the x it should be minus 1.001x, and then equal like this one minus this one is 0.075 minus. How about, and then we ended up getting x like around 0.075, or which is equal 7.5%. Okay, 7.5%. And now we need to determine one by one. So x itself is this one. Okay, x itself, this one, 6 lithium. So x, this one is lithium, and then the number of x is like 7.5%. Okay, so we already get the answer. It should be A. For 6 lithium, 7.49, right? And then for lithium, 92.51. All right, that's good. That's good at all. And then number 18, remember, but just remember this equation. Every single question about relative abundance or abundance of isotope, using the average and then mass times like the ratio over here is x, and then another one is 1 minus x. So it's kind of like a little bit tricky, but if you understand this concept, you will get much more like easier to solve this problem. It's just like to math. Okay, just do math of this problem. All right, number 18. Which group contains non-metal, metalloid, and metals? So, as you can see, guys, okay, as you can see, this one is transition. Okay, this one is transition metal, and then this one is metalloid. The gray one is metalloid. Okay, and then the red one is like non-metal, and then this one is halogen. Okay, halogen. All right, just remember this part, guys, because this part is so important. Okay, this part is so important. So because like I don't know if they will, I mean, in the exam it will ask about, I mean, we will getting question about something like transition metal. Probably not. I'm pretty sure they just like wants to give us this part, not all of part about transition metal. Hopefully not. Okay, so non-metal and then metalloid. So the question is, which group non-metal, metalloid, and metals? This is group, right? This is group, and so on. Okay, which group that contains a lot of things like metal, non-metal, and then non-metal, metalloid, and metal. Okay, as you can see, guys, in the 13 over here, in the 13, okay, P, boron, sometimes it might be metal, it might be non-metal. Okay, it might be metal or might be non-metal. This is the thing that sometimes make me confused, because we don't have any like good standard of the periodic table. Even this one is from the ACS, but sometimes like we have another like term, another illustration. Okay, so for the number 18, okay, for the number 18, like which one that contain non-metal, metalloid, and metal? Okay, let's see. Okay, this is not but for over here we can see the but because this question, I mean this exam is based on the ACS, so yeah, it might be good if we are using this reference, okay, not using another reference. Okay, so which one that contain, you can see, as you can see, the 13 not containing any non-metal, okay, not containing non-metal. This one containing non-metal, containing metalloid, and then containing like metal. So 14 also. But in this case, in this option, they don't give us option 14. Let's take a look at 15. Okay, let's take a look at 15. Okay, so it should be same, right? 15 is, this is a non-metal, and then this one is metalloid, and then this one is metal. So the 15, 14, 16, like 3 of these groups have kind of like metal, non-metal, and metalloid. Okay, so the answer should be C. And then again, number 19. What's the main group element? What is a main group element? Okay, main group element is like group 1, 2, 13 till 18. Okay, this is the main group. This is the main group. Okay, the main group. Okay, so 1 to 2 and then 13 to 18. This is the main group. Okay, so what's the main group element over here? And then you can take a look at one by one. So just magnesium, that's still in the main group. Okay, magnesium. Okay, so others, you're just matching up with the periodic table. As long as you understand what's the meaning of the main group, you will get the answer. Okay, remember the main group is 1 till 2, 13 to 18. So the answer is just matching up between the option and the periodic table. All right, the halogen are found in group, the halogen, this is the halogen 17. Okay, that's all. It's pretty easy, right? It's pretty easy. All right, and then another question again. All right, so we need to get some rest, guys, because it takes so much time to solve like all of the problem. And then for the next time we move on to electronic structure. Okay, which is typically this material aligns to electronic structure or quantum in the textbook. So but sometimes the name of the chapter might vary, so please, if you like wondering, like wants to like dig into it, just refer your textbooks. Okay, so for the next step, we are discussing about electronic structure stuff. Okay, and then we gonna discuss again about the next question for 21 till 25. Okay, so it's quite easy for us to understand this part because yeah, we just need to have what can I say, we just need to have a periodic table and then understand it. Okay, all right, let's walk through 21 till 25 with explanation. All right, number 21. Which compound contains a group 14 metal? 14, guys, this is 14. And then as you can see, remember that the pattern kind of like this one. Okay, so remember the pattern. This is 1, this is 2, 2, 2. Okay, remember 1, 2, 2, 2. Okay, 1, 2, 2, 2. This another one is, this one is 5, 3, 2, 1. 5, 3, 2, 1. Just remember the pattern. Okay, and then another one again. Okay, now we goes through we walk through one by one for this question. Good. Okay, so which one that metal? Which one that metal? Which one that metal? Just silicon, right? And then germanium. Okay, germanium. Just silicon and then germanium. Okay, germanium and sorry, not silicon. Sn is S what? Germanium, and then Se, yeah, Si is silicon. Yeah, that's true. That's true. And then sometimes it also Sn, but yeah. Okay, so in which compound? So over here it's just germanium. Okay, Sn not, it should be not. Sn should be not. Okay, so only germanium. Okay, yeah. So always refers the ACS periodic table, because sometimes we can get wrong if we are looking at another reference. Okay, I already double check, but let me see. Oh, this is metal, not metalloid. Oh yes, metal is the black one. Sorry guys, that's true. Metal, this one is metal, the gray one is metalloid. So this one is metalloid. Sorry, that's why I'm confused. Like, why silicon is metal? Silicon should be not metal, just metalloid. Okay, not metal, silicon. Okay, remember. Okay, just this part that metal. Okay, not metalloid. So which one is should be Sn? Okay, tin. Okay, should be tin. Germanium is silicon. Okay, only two over here, germanium or tin. But the because of the question is regarding the question, it should be metal. The question is about metal, so we choose the B1. Okay, all right, the correct answer is Sn dichloride. Okay, tin dichloride. All right, and then again, which statement below is correct? Okay, chlorine is transition metal. No, chlorine is halogen. Okay, chlorine is halogen. Okay, so not transitional metal. No, this one is not. Oxygen is metal. No, you can see, as you know that oxygen not metal, right? And then sodium sodium Na is metalloid. I don't think so. It should be metal. Okay, sodium, it should be metal. Okay, it should be metal, not metalloid. Phosphorus is non-metal. Phosphorus is non-metal. That's true. We already eliminate one by one. Okay, non-metal. Where is the non-metal? Phosphorus, this one. Okay, P, non-metal. That's right. And then which compound, and then move to another equation again. Which compound below contains transition metal? Remember, the transition metal is like in this region. This region. Okay, this region. So which one? Okay, if there is something not in those region, which means it's incorrect. Na. No. Na is metal. Okay, Na over here. Na. Okay, and then aluminum, Al, aluminum over here is other metals, not transition, other metals, so it should be not. And then how about the VO2, vanadium. Okay, VO2, vanadium. Okay, vanadium dioxide, so it should be this one. So we already got it, the answer. And then B should be over here. So BF3, P is metal. So the transition one, it should be C. And then again, which element is alkali metal? Alkali metal, this one guys. This is another one, the first one. This is alkali earth. Okay, alkali earth. another one is alkali metal, this one. Okay, remember this one, the first one is alkali metal, another one is alkali earth. This is the metal, but sometimes it's metalloid. And then another thing is non-metal, and then halogen, and then other stuff, right? So which element that in alkali metal? So you just take a look at this part. Le, Li, Na, K, Rb, Cs, Fr. So the answer should be what? Should be A, right? Should be A. It's pretty easy. Oh, sorry. It should be A. Yeah. Where is the one? Okay, not this one. Okay, for 24, the answer is A. Okay, 24, the answer is A. And then again, which element is actinate? Actinate. Okay, actinate is atomic number from, so atomic number from 89 till 103. So as you can see, which one that actinate? So this one, the green one, actinate, 89 to 103. Okay, the green one. So yeah, we can eliminate one by one. Rb is alkali metal. Okay, alkali metal. And then uranium, yeah, uranium is actinate. Actinate. And then Mo, monobdelum, is transition. As well as for Ga is transition. Ga is transition. Ga. Okay, still this one, we cannot say transition, sorry, but like post-transitional metal. We can say post-transitional metal. Post-transitional metal. Okay, good. So the answer is should be P. Okay, yeah, we can do kind of like another, I mean, we can do elimination process for each option. And then the last part of this topic about atomic structure before we are moving to another part. So hopefully I can finish for all of part, okay, all of part, like maybe 10 days or 15 days. Hopefully I can do soon, okay? Or yeah, so I need to study of this part as well. All right, so we move on to 26 till 30. 26 till 30. Okay, let me check it first, the periodic table, and then we move on to another part. All right, so okay, magnesium forms an ionic compound with element with the formula Mgh. Which ion could be? Remember, Mg is 2 plus, right? So we want to see, we want to like choose which one that has -2 for X. Okay, it should be -2 for X. So let's check it one by one. This is -1, this is -3, this is -4. So Mgs, right? Mgs. So Mgs would give Mgs. Okay, formula would be Mgx, not possible if both are 2 plus and 2 minus. So oh wait. So Mgs. Oh, magnesium form ionic compound with element with the formula Mgx. Oh, I got you. So what this one want to make it neutral ionic compound. Okay, so X must be -1. Okay, it must be -1. Sorry, I'm not careful to read the question, because as you can see, the question is asking about No, no, yeah. It should be D. It should be D. Yeah. Magnesium form an ionic compound with element with formula Mgx. Which ion could be X? It should be Mgs2. Might be there is something wrong with this equation. Or maybe MGPR. Yeah, if MGPR, I'm still thinking. Magnesium form an ionic compound. But if we are using MGP, but it's kind of like weird, MGP. But I'm not sure why the equation is ionic compound over here. Magnesium form an ionic compound with element with formula Mgx. It should be D. It should be D. It should be D because, but I'm not sure. I'm not sure. To make neutral ionic compound with formula, X must be -2. It should be -2, right? Not minus, or no. It should be D. It should be D. The answer is should be D. Yeah, the concept is good. +2 and then -2. Yeah, it should be D. Okay. Let me clarify first. Number 26. All right. So alkaline earth yeah, we move on to another part. Okay. We move on another part. Yeah, it should be D. Yeah. No, I mean not because of this one. So it should be neutral. The thing that I already understand that it should be neutral. But when I'm take a look at like detail, it should kind of like ionic compound here is make me confused. Okay, but it's good. The equation, the answer is should be D. Alkaline earth metals form, okay, alkaline earth, okay. As you can see, the first group is alkaline metal, and then the question here is about alkaline earth. Alkaline earth is this part, the second part, the second group. Okay, so the answer is should be +2, right? It should be +2. Okay, the answer is should be +2. All right, and then move on to another question. Which compound contain +1 ion? So this is -2 +2 -1 +1. So the answer is should be B. Okay, it should be B. What is the formula for the compound formed when aluminum ion Al3 plus combined with an oxide ion O2 minus? So how to do it? Al3 plus with the O2 minus. So it's pretty easy. Okay, it's pretty easy. How to do that? We just use the valence to valence charge. Okay, LCM of 3 and 2. Okay, LCM of 3 and 2. What's the LCM 3 and 2? It should be 6, right? It should be 6. Okay, so Al to achieve 6 need 2. Okay, is it right? So 3 times 2, it will give us 6. It ended up 6, right? And then how about the O? Because the O has like -2. So to achieve 6, we need to have at least 3. We need to have 3. Okay? So both for all of them overall, it will give us like LCM 6. Okay, so the formula is Al2O3. Okay, Al2O3. So the answer is should be B. And then the last question for atomic structure: if gallium atomic number 31, atomic number 31, okay, remember atomic number, okay, combines with the selenium, combined with the selenium with the atomic number is 34. Okay, what is the most likely formula based on your knowledge of the periodic nature of the element? Okay, how to do it? That same thing. That's the same thing. We can do the LCM as well. Okay, as long as we understand, or as long as we know in where are the position of both elements in the periodic table. Okay, so GA over here. Okay, GA over here. So over here it should, like, commonly it has +3. Is it right? Yeah. And then a selenium is over here. Selenium is over here. So it's typically has -2. Okay, -2. So we need to get the LCM between 3 and 2. What's the answer? It should be 6, right? What's the answer? It should be 6. So to balance chart, it should be using the LCM and then 6, right? So how to do that? We can understand GA is 3 plus and then SA is 2 minus. Same with the previous one, but they don't, I mean, in this question, they do not provide, they don't provide the charge of each element. So what we can do is same. How to achieve 6 if we have over here like +3? Yeah, we need to have 2 GA. Like, okay, we need to get 2 Kalium. And then how about the selenium? Selenium 2. So it should be, selenium should be 3. So Ga2, selenium 3. So the answer, it should be D. Okay, so that's all, guys, for all of question about atomic structure. Just like I mentioned, you need to understand the concept behind it. Okay, and then we will do more for another question one by one, like this video and then the previous one. Okay, see ya, bye bye, and then nice to meet you, and then we will meet again for another topic, which is about electronic structure. Okay, thank you.